Hello and welcome to this video. My name is Rohit Prajapati. Students call me RPM sir. Recently I came across a question which is an old question of JEE Advanced and I came across its solution in a book. Now here the solution given is fine. It is analytical solution, but I thought that few students may feel difficulty in understanding the concept or they might not feel this solution to be intuitive. Let us discuss this question and I will try to explain the question graphically in a different manner so that it is more meaningful for the students. And as always, I try to emphasize on the graphical aspect whenever possible. So let us understand the question. In this question, a function fx is given. It is integral part of x cos 2x minus 1 upon 2 times pi. And they are asking for a function to be discontinuous at which of the following options. So here if we understand that the given function is product of two functions. The first function is integral part of x and the second function is cos 2x minus 1 upon 2 times pi. And our resultant function fx is product of these two functions. Now according to this solution, they define function in certain interval. The interval starts from minus 1 to 3, goes up to 3, and they try to check continuity of the function at 1 and at 2, and then they said that in this manner we can observe that the function is continuous at every integer. But a student may ask a question that they checked only at 2 points. What will be the possibility, or will it be continuous for every integer other than 1 and 2 or not? So let us try to solve this question using analytical approach as well as graphical approach. So first of all, we should understand that this second function which I can observe is that it is cos 2x minus 1 upon 2. I can simplify this function a little bit. If somehow I am able to simplify this function, I can comment regarding its continuity in an easier manner. So this second function can be written as cos. If we split this into two parts, it becomes x minus 1 by 2 times pi. If I multiply pi inside, it becomes cos pi x minus pi by 2. And for cos, everyone knows that pi x minus pi by 2 or pi by 2 minus x, pi x, both are same. So cos pi by 2 minus theta is sine theta. Ultimately, it becomes sine pi x. So now I can say that my question is fx equal to integral part of x multiplied by sine pi x. Now I think the second function is simplified a little bit. Sine pi x is easy to visualize, and if we want to visualize it graphically, we can easily do so. Now understand one more point. When two functions are given in product, then we can comment about continuity and discontinuity using some fundamental principles, using individual continuity and discontinuity of both the functions. So initially if we observe this integral part of x, everyone knows that this integral part of x is discontinuous whenever x is an integer. So this function becomes discontinuous for all x belonging to integers. So whenever x is an integer, this function is going to become discontinuous. And what about sine pi x? Look, sine x is a continuous function. It is always continuous. If we changed angle as pi x, then also it remains continuous because we only scaled the function. Now function has been compressed by a factor of pi, but the continuity is not compromised. So this function is continuous for all x belonging to R. Alright. So according to basic fundamental theorems on continuity, what we know that if one of the two functions, one of the given two functions is continuous and the second function is also continuous at certain point, then the resulting function formed after the product will always be continuous. However, if among the two given functions, one is continuous and the other one is not continuous, then nothing can be said about discontinuity of the resultant function. So what we observe here is that the continuity of the entire function can be compromised only at those values of x which are integer, because whenever x is not an integer, the first function integral part of x is continuous, as well as whenever x is not an integer, the second function sine pi x is also continuous, so my resultant function has to be continuous. Continuity can only be compromised at integer values of x, because at those values of x, the first function is discontinuous, whereas the second function is continuous. So now I think we should check for integral values of x, and we should check whether the entire function is continuous at integral values of x or not. In this solution, they only checked at x equals to 1 and x equals to 2. However, their method is also same. But I thought of checking this at a general value of x, which is an integer. Alright. So let us try to check for the second function. Now, as we know that our function is fx equals to integral part of x, and after simplification, the second part became sine pi x. Now, let us consider a general value of x which is an integer. So let there is some value of x and this value is an integer. So at x equals to n, if I check left hand limit and right hand limit and the value of the function, if all of them are same regardless of the value of n, then the function has to be continuous for all the n which are integers. Alright. So let me try to find left hand limit at x equals to n. So it is limit x tending toward n from left, and my function fx, which is integral part of x sine pi x. Now, because the first part is integral part of x and x is tending toward an integer n, but here x is slightly less than n, so I can redefine my function as x tending toward n from left, and this first part, which is integral part of x, will become n minus 1. Why n minus 1? Because x is slightly less than n. If x is slightly less than n, the integral part function will take a value which is immediate left integer, or the integer which is immediately smaller than n. So it is n minus 1. However, this function sine pi x remains as it is. So now it becomes n minus 1 goes outside, it is a fixed integer, and we know that when x tends towards n, this angle of sine will try to tend toward n pi, and we know that at n pi means integral multiple of pi, sine is 0, so this second term will become 0, so left hand limit of the function becomes 0. Similarly, we can check right hand limit of the function. So RHL of the function will be limit x tending toward n from right, integral part of x and sine pi x. Now again same thing, x is slightly greater than n, where n is an integer, so integral part of x will become n, and sine pi x, again sine pi x is trying to tend towards sine n pi, which is 0, so it becomes 0, so right hand limit is also 0. And obviously, if I try to find value of the function at n, which is some integer, integral part of n is n, and this is sine n pi. So integral part of n becomes n, and sine n pi becomes 0, it becomes 0. Alright. So as we got a result that LHL is equals to RHL equals to value of the function at a certain point. So I can say that my function is perfectly continuous whenever x is an integer. And I checked for a general integer. I did not put any particular value of n like 1 or 2. So this procedure or this method is a general method, and my function stands continuous for all the values of x. Because when x was not an integer, these two functions were continuous, so the resultant product function has to be continuous. We only suspect at those values of x which is an integer. Now we came to know that at integral points as well, my function is perfectly continuous. So according to the option, they are asking that function is discontinuous at, well, the answer will be at no value of x. Alright. Alright. Now let us try to find a graphical approach. A graphical approach in which we don't have to calculate anything, rather than if we estimate the graph of the function or we can visualize graph of the function, then we can directly comment regarding continuity and discontinuity of the function. Even from graphical technique you can also predict the points, or you can also find the points at which the function is non-differentiable, because they can create a question based on same function in which they ask us to comment about the discontinuity as well as non-differentiability of the function. Alright, so let us understand this method. I know this video is going to become slightly lengthy, but our discussion is going to be deep, and the main intention is not to solve problem rather than focus on various techniques and proper understanding of the problem. So the function fx equals to integral part of x into sine pi x. Now as we know that there is no direct method by which I can plot graph of product of two functions when individual graphs are given. But I can anticipate or I can estimate values of the product function at certain points. So how does graph of integral part of x look like? We all know that this graph is discontinuous at so many points in its domain. So from 0 to 1, the integral part function remains 0, and then it takes a jump and then continues to remain constant for a while, and then again jumps and remains constant for a while. So whenever x is integer, integral part function changes its definition. And what about the second function, which is sine pi x? We know that sine completes a cycle for a duration of 2 pi, but this is sine pi x. Sine pi x means we have scaled sine x. Because you scaled by a factor of pi, it means the point which should have been placed at pi is now placed at pi upon pi, so it becomes 1. This point was supposed to be 2 pi in graph of sin x, but now this point will become 2 pi upon pi, so it will become 2. Alright, so every half cycle of this sin x is now being completed in at a duration of 1. So at every integer, sign goes from positive to negative now. Sin pi x changes its definition from positive to negative and negative to positive at every integral point. And at the same integral point, the first function integral part of x also changes its definition. So what will happen when we multiply the two functions? Let us multiply the two functions pointwise. So when x is 0, integral part of x is 0, sine pi x is also 0. So the resultant function has to lie at a value of 0. As the value of x increases, sine goes upward, reaches a maximum value 1. However, this integral part of x remains 0. So the product function has to be 0. So my resultant function lies at a level 0. Alright. Now, when x reaches exactly 1, sine becomes exactly 0. However, integral part of x becomes 1. So the product has to be 0 again. Alright. Now we can observe between 1 and 2, integral part of x has a value 1 and sin x has a negative value. When sin x is multiplied by 1, nothing changes in the graph of sin x. So the graph remains as it is. From 1 to 2, graph remains same. Now 2 onwards, what happens? Between 2 to 3, integral part of x becomes 2. So 2 is multiplied to each and every value of sine pi x between 2 and 3. Earlier, the maximum value which sine pi x can achieve was 1, but now this maximum value 1 is multiplied by a number which is 2. So it reaches a value 2. So instead of reaching at 1, now amplitude of this function has increased and this goes up to a higher value 2. As we move ahead, we can anticipate the next value taken by integral part of x is going to be 3. So 3 will be multiplied to the next part of sine pi x. Its magnitude will further be stretched but in negative direction. So it seems like function is trying to increase its amplitude, the resulting function. And what happens before 0? Here, integral part of x assumes a value minus 1. So this minus 1 multiplied by this negative value of sin x, magnitude does not change because 1 is multiplied to each and every value of sin pi x in the duration minus 1 to 0. But these two after multiplication becomes positive. So in this direction, graph of the function is somewhat like this. And further, the same thing will happen. Its magnitude will increase by a factor 2, then by a factor 3, and so on. Okay. So you can check here that when sin x and integral part of x lie between any two integers, the resultant function is perfectly continuous. And it has to be continuous because both of them were continuous. But whenever integral part of x is discontinuous, at that point what's happening is that sin x is reaching toward 0. Because sin x decreases its amplitude, that's why the resultant function also reaches at a value 0. And as a consequence, the entire function becomes 0 and the resultant function is continuous. Alright, so we can say graphically that the function is continuous for all the values of x. Now, let us see graph with more clarity, like these graphs I have drawn with my hand. Let us see a proper graph of these functions. So here I have depicted graph of the two functions. With green color we have sin x, with blue color we have integral part of x. And when we multiply these two functions, all these values of integral part of x which are 0 are multiplied by these values. So it becomes 0. So the final graph becomes 0. Alright, so this is the graph. So what happens between 1 and 2? Integral part function achieves a value 1. This becomes negative, so nothing changes in the final graph. Then when these two values are multiplied together, the amplitude of this graph increased by 2. The same thing. So when these two are getting multiplied, what happens to the resulting graph? The resulting graph looks somewhat like this, what I said earlier. Alright. So you can see this graph is perfectly continuous. And one more thing, we have a property that whenever two functions are multiplied, and if among those two functions, let's say the two functions are fx and gx, so whenever one of the two function is continuous at certain point, let's say x equals to a of its domain, and the second function gx is discontinuous at same point x equals to a, then we say that nothing can be said about continuity of the entire function. It means the entire function might be continuous, may not be continuous. Anything may happen. Alright. So the property says that nothing can be said, but we want to say something about it. We want to say something about this case. We want to extract some details through this question and we want to generalize this concept. So what is the concept? Look at this. The two functions under our considerations are such that one function is continuous, which is sin x. So our function sin pi x is perfectly continuous. Let me change the color. All right. So the first function, which is sin pi x, is perfectly continuous, whereas the second function, integral part of x, is discontinuous. But whenever integral part function, the second function, becomes discontinuous, exactly at those points, the first function is tending towards 0. Okay. So what happens because of this? Look at this. When these two are multiplied, they create a perfectly continuous function. And because one of them is tending towards 0, so the resultant function has to return to 0. But after this point, again, the integral part function jumps. However, sin x was sitting at 0, sin pi x was sitting at 0. That's why the resultant function cannot change instantly. Sin x increases its value slowly in the negative direction, and all these values multiplied by 1 remains very small values. Same thing happens at 2. At 2, what happens immediately before 2, the product of the function was similar to the graph of sin pi x. When we were approaching 2, at that time, this sin pi x was approaching towards 0. As a result, product of both the function tends towards 0. Immediately after this point, integral part changes its value suddenly. It becomes 2. It takes a value 2. But that value 2 cannot be attained immediately by the resultant product function. Why? Because sin pi x was sitting at 0 and it starts changing its value slowly when we reach immediately in the right neighborhood of 2. Sin pi x is increasing slowly and it is near to 0. As a result, product of this 2 and sin pi x is tending towards 0 on right hand side, as well as product of this one and sin pi x in the left neighborhood is also tending towards 0. And of course sin pi x is 0 at 2, that's why the resulting function is 0, and that's how we can say that the resulting function will remain continuous. All right, so this is all about the graphical explanation. Now we can generalize a concept. Like I said that we will now say something regarding continuity of the product function. So now looking at this concept, we can say that if fx and gx, two functions, are such that at certain point x equals to a of their common domain, one of the function is continuous and tending toward 0 at that point, or you can say fa is 0, whereas the second function is discontinuous at same point. So whenever in a product function one is continuous, second is discontinuous, but the function which is continuous is 0 at the point of discontinuity of the second function, the resulting function has to be continuous at that point, maybe x equals to a, at which we are talking about. Alright, so this is the final concept. Hope you understand this concept. Thank you so much.